Hi, Mrs. Jacobs here, physics teacher at Naperville North High School, here to do a tutorial about how to calculate slope from a linear graph. The general format to calculate slope can be written in two different ways. Overall, it's the change in y over the change in x, which we write as delta y over delta x, delta meaning change in. Another way to say that is rise over run. Another way to do it is y2 minus y1 over x2 minus x1 when you have selected two different points on the linear line. Now, the way that you calculate slope in math is the same way you're going to calculate slope in physics. The only difference is we're going to have units that go with the y. This is the unit of the y on this graph, meters per second. And unit of the x is in seconds. So we're going to include those units as we calculate our slope. Let's do a situation here where we're calculating the slope of segment A. I'm going to model first the y2 minus y1 over x2 minus x1 format. I can select any 2 points that are on this line. I'm going to go ahead and select 0, 0, and this is 0 seconds, comma 0 meters per second. So I have 0 time and 0 velocity. Up here, no, I'm only on the 6th square, but you got to look at the scale on the y-axis. Every square is 2. And so that's why this is 12 meters per second. That's for the y. Let's talk about the x. 4 seconds is the x. 12 meters per second is the y. So if I'm going to do the slope of A, it's going to be y2 minus y1. So 12 meters per second minus 0 meters per second. This is my y2. This is my y1. I subtract them in the numerator. This is my x2. This is my x1. So it's going to be 4 seconds minus 0 seconds. So my answer is going to be 12 meters per second over 4 seconds, which is 3. And then I keep the unit meter per second per second. Okay, seconds doesn't actually cancel out when it's on the bottom here and on the bottom here. And that is the answer for the slope of segment A. Another way to get it, if you would rather just do rise over run, is to draw what I call like a slope triangle on the graph to say, okay, here, this triangle is 2 seconds wide on the base and 6 meters per second tall on the height. So if I were to do rise over run for that triangle, the rise is the height, 6 meters per second. The run is the width of the base, 2 seconds. I end up getting the same exact answer. Okay, so those are probably the two most common ways to find slope, doing the y2 minus y1 over or doing rise over run based on a slope triangle that you've drawn. Let's do one more example for segment B over here. Okay, I think it's important to know that we should anticipate that we should get a negative answer because B has a negative slope. Okay, if we don't get a negative answer, then something went wrong. I'm going to have here 4 seconds and 12 meters per second still as my first point, but now this is going to be x1 and y1. And my second point for x2 and y2 is going to be, this is 12 seconds in the x and 0 meters per second in the y. So when I calculate the slope of segment B, it's going to be y2 minus y1. So 0 meters per second minus 12 meters per second. That's where that negative is going to come in because my numerator is going to be negative over 12 seconds minus 4 seconds. So I'm going to get a negative 12 over 8. Which is going to reduce down to 3/2 or 1.5. Negative 3/2 meters per second over seconds. Again, if I draw a slope triangle, I'll draw, let's say, this triangle. This is a run of 4 seconds, because it went from 8 to 12. This is a rise of -6 meters per second, because it's going down 6 seconds. It's important to know that if you're going to do rise over run, you have to keep track of whether that rise is positive or negative. So rise over run for this would be -6 meters per second over 4 seconds, which gives me the same answer. And you could put it in decimal form if you would like, -1.5 meters per second. Here is a second practice situation where you have 3 segments, A, B, and C. This is a position versus time graph. So meters is on the y-axis and time is on the x-axis. Go ahead, pause this video, and see if you can calculate the slope of each of these segments. And then I will show you the answers. For segment A, I got +1/2 meter per second as my slope. For B, the slope is 0, it's a flat line. For C, the slope was -1 meter per second. Hopefully this was helpful.